Hi everyone, welcome back to another round of AI End Show. We have with me today Juan Marcano from Uber. And Juan, welcome to the podcast.
Oh, thank you.
Yeah. So just a quick intros about ourselves. I'm Parth. I'm staff engineer on the Michelangelo ML platform team working on Feature Store and GenAI. Juan, you want to give a quick intro?
Yeah, I'm a staff engineer working on bringing AI to automate a lot of the menial tasks, such as the one that we're going to talk about today. Although that one was not super menial. It was very complicated.
Yes, yes, absolutely. So Juan published a really wonderful blog about how Juan and team basically went out about changing the way the mobile testing is done in Uber. It's a very cutting edge idea. I think the product is called Dragon Crawl. So let's dive straight into it, Juan. Basically, help us walk through like
Mhm.
what was the scene of mobile testing before you started this work, and then what kind of motivated you to do this?
Yeah. So before I joined Uber, or right around the time I joined Uber, I talked with the former director of the testing infrastructure team, and it was pretty much 100% manual. So, Uber was behind the industry. And yeah, so before I started at Uber, Uber was doing mobile testing 100% manual or mostly manual. And then our team started to build platforms and frameworks so that people could script automation testing. And, that was a pretty good step. But my director back then, his name is Homer Lockby. He would say, "Oh, look, these things break, and then we need an army of people to go back and update the tests. Tests need to be updated." And that, when we quantified it, it was like 30 to 40% of engineers' time, and it was millions and millions of dollars spent on that. And that was pretty bad. And the other problem with that, I mean, if this is not a big problem alone, the problem with that is that because the signal to noise ratio was so low, you know, you couldn't really rely on those tests to block PRs. Uh, you had to use your eyeballs to look at screens and decide what happened. And then the other difficulty was that Uber apps are almost entirely different products from city to city because of regulations or this or that. So it was going to be extremely difficult to test all of those different combinations. And then that's when we're like, yeah, the only way here is machine learning. The models should look at the screens, look at the goals of the test, and take actions. And if they're thrown curves, they should think on their feet and then take the appropriate action. And that's why we built DragonCrawl. DragonCrawl I started it in 2019. And there were lots of failures between, when I started and when the blog was published. And one of the things that we tried with a third-party company was to use uh, some rudimentary computer vision. So, analyzing the screens using a bit more sophisticated computer vision in around 2021. And that had some potential. But then, people we started to have failures, and the people that I was building this with, they'll quit. So, I was left alone. And then in 2022, uh, I was like, we should use computer vision for sure. They need to look at the screen or a viable representation of the screen. And the model should reward itself for taking the right action, touching the right buttons, or avoiding certain buttons. So that's when I said, okay, computer vision and reinforcement learning. And that reinforcement learning, I don't want to go too deep into it, but you have to craft a policy, which, you have to write a somewhat complex Python script. Sometimes you make it ugly. You tend to make it ugly. uh, and a file where you kind of program the rewards and the punishments for the model. And that worked really well. But then we're like, oh, how are we going to scale this thing? Like, I cannot ask a mobile engineer to uh, come in and make this file with the reward. Like, they're not going to understand that. It's even a bit difficult for me to even think about that. And then we got tipped off by some friends at Stanford that LLMs could be used to replace reinforcement learning. And these friends of mine, they ended up proving it mathematically. And I was like, oh, okay, yes, nobody's going to write these policies. We're going to use the LLMs for that. And the paper for reference, I think it's called "Why Your LLM is Secretly a Reward Model" or a reward something. So that was when we got that inspiration, that tip. We're like, yeah, let's go after this. And yeah, right now and for like the past year or so, people have been defining their tests in plain English. Hey, request a trip, just like that. Your test, in some cases, it just comes down to one sentence. In some other cases, yeah, you provide long instructions. The mobile engineers for the SDETs, uh, what they started with was pretty simple. Just defining in plain English what the test is like. Request a trip. Touch this button. Go back because we want to make sure we don't break when we go back. Things like that. Just in plain English. Step 1, 2, 3, 4. So that was how we started, and then when people started to see things coming out well, us
Yes.
preventing outages, all of these good things happening, uh, we went on to more complex stuff that, uh, well, we cannot really talk much about it because it's not in the blog. Uh, but the
Yes.
concept of MCP is super popular right now. Tool calling is also super popular now. Uh, well, let's say that we kind of transformed the SDET job from writing Appium to working on MCPs and tool calling. Exactly. And the funny thing is a lot of people thought we were going to be the end of SDETs. But no, we transformed their job. And from what some people tell me, SDETs want to come to Uber because as they pick up really, really hot skills. Yeah. So
Yes. So,
you
but
have, the steps, the goals of the test. You put them somewhere in plain English. And that is part of the input. The other part of the input is a text representation of the screen. So the emulators, we take a dump in XML format of the screen,
nice.
this text representation, this formatted text representation of the screen, and the past action that we have taken. So for example, if you're already logged in, if we already, enter the user information, we just say, hey, touch this button, touch that button. So we combine those three things into a prompt. And then that is the input. And then the output that Dragon gives you is the action that is most likely to get you to the goal. So for example, if you are, in a screen where you are about to request a trip and you have that the goal of the
Yeah.
test is to request a trip,
Yes.
most likely you're not going to close the app. Dragon is not going to suggest to close the app. It's not going to suggest to scroll randomly. It's going to suggest to touch the confirm button or a payment if it says it's missing or whatever. And so the language of the app itself tends to correlate very heavily with the goal. So that is what we're leveraging here. The other thing, right? So like you said, you have to specify, hey, touch this button. This is the name of the button. What happens in the over apps is that
Yes.
the names of the button change. The text in the buttons change, the location, or you get a pop-up. And like every single one of those small things used to break our
Got
test.
it. Okay.
If the name of the button changed, then that test would fail. Right now, and this is something that we have said publicly before in various forums, we make assertions visually. So it's not about the ID of the button. It's not about the location of the button, unless that is what you want to check.
Yeah.
It's more about, hey, is
Yeah.
the button there? Or I don't know, are we showing alcohol drinks without, without specifying a brand or anything? Like you can ask for a pretty abstract construct and and get a response that really surprises people. Good. We had a budget of how much time we could allow ourselves to execute this test. So it couldn't be a
Yeah.
huge model
Yeah.
that would, take a long time to run. It couldn't be a tiny model that would not perform. So, and by the way, back then for me, tiny was 1 million parameters. Uh, first for some other people back then, tiny was 100. Uh, so, anyways, different definitions of tiny. But we ended up with trying these models. I forgot with how many parameters. Uh, they were all like 100 to 1,000 times smaller than what we presumed was GPT 3.5 or GPT 4, and uh, we fine-tuned them to see if we could use them to take us from beginning to end. We wanted to measure the latency. We wanted to measure the steps the model recommended at every single point. So what that means is that when you're in a screen and you ask Dragon, it says, for example, touch the request button, or action number two, the option number two is to touch whatever, this or that, right? So Dragon recommends actions, and we wanted to assess the accuracy of those recommendations. And ideally, the first one, we want it to be 100%, right? Ideally, we always take the right action on the first attempt. But, sometimes we make mistakes. Something that we have shown in a different presentation is a driver getting a pop-up, and Dragon tries to get out of that situation, and he tries it once and it doesn't work, but then he tried it again and then that worked. So, you cannot try 50 things. You have to get it right on the first or the second. And that is how we crafted the metric. See, like Dragon is doing the things that humans do, like, restarting the app or touching this button or that button to, to close the thing so we can complete that trip or request that trip. Yeah. That was one of the happiest days of 2023 for me.
Yeah. That's very nice, right? Like,
Or something time it went online against what we programmed it, which scares some people, excites other people. But like imagine if we had filed an incident because of it. It just took some retries. Maybe the emulators where the tests were running
yes.
had low internet, bad internet. I don't know, or maybe we were having a minute issue for like 2 minutes. If you file an incident just for that, like you disrupt so many developers, and the screenshots, the videos would really make you think that something really bad is going on. And sure, Uber not working for a minute or two is bad, but it's not the end of the world. By the time people look at it, it's
Understand the customer pain point without having to get direct customer feedback. You kind of resolve those issues early on rather than waiting for customers to not like your app. Yeah.
the most fun part. You know, Definitely the most fun part was when those quirky things were happening, like when it restarted the app, when it decided to wait something out and then it didn't actually work, or when it tried to go online relentlessly. Like every time I see something like that, I laugh and smile and all of that. uh,
Sounds really very, very exciting one, and what you worked on is cool and cutting edge. So Thank you for joining us and sharing all this wonderful work you have done. And I'm sure, hopefully, listeners will learn and get inspired. I'm inspired definitely with what you have done, and looking forward to seeing more great work coming from you. Thank you.
Thank you. Thank you. I also appreciate coming here because this is episode number 2, and episode number 1 was your own baby. So it's a big honor.